Hi there, welcome to my channel. In today's video, we are going to solve this medium lead code problem. Problem number is 55, jump game. Let's understand the problem first. They are saying you are given an integer nums. You are initially positioned at array's first index, and each element in array represents your maximum jump length at that position. Now we have to determine if we can reach to the last index or not. So if we are able to reach the last index, we will return true, else we will return the false. In the first example, we are given this array. Now in this array, we can from this first index 2, we can take either one jump or two jumps. For the first case, let's jump once from here. So if we jump once, we will land over here on index 1 where the value is 3. Now from this index, from 3, we can take either 1, 2 or 3 jumps. Now if we take one jump, we will land here. For two jumps, we will land here. For three jumps, we will land at 4. So this 4 is reachable from the first index. In this case, we will return true. Let's see one other variation. So what if from here, from 2, if we took one jump and we landed at 3, but from 3, instead of taking 3 jumps, what if we have taken 2 jumps? Then we will land here. Now from this one, we can again take one jump, we will reach 4. So there can be multiple paths to reach the last element. We have to determine that there exists at least one such path which leads it to the last index. If any of such paths exist, then we will return true. If there is no such combination there, then we will return false. Let's see the example 2 now. Here in this case, if we see from first index, the value is 3, we can take either 1, 2 or 3 jumps. If we take one jump, we will land here at 2, and from 2 now we can take either 1 or 2 jumps. So if I take one jump, I will land at 1, and from 1, I will be able to take only one jump that will lead to 0. But now at 0, I can only take 0 jumps. It means that I cannot move from here. So we are not reaching the last element, that is 4. What if from 3, I took 2 jumps? Then I will reach here. Again, I have to take one jump from here to this index, and again the path ended here. We can have other such combinations also. So now we are seeing in this example, we are always landing at this index where the value is 0, and we will not be able to move further. So in this case, we are not able to reach the last index, hence we will return false from here. Let's have a look at the constraints now. It's saying the length of that array will be between 1 to 10,000, and its values, the value of the elements will be between 0 to 1 lakh. From first, we can say that we always will have at least one element. If there is only one element, it will always return true. And the constraint 2 is just about the limit of values. Instead of trying to reach the last element in this direction, what we will try, we will go from last to first index, and we will see if we are able to reach the first index here. Now how we will do that? We will set our pointer for the last element here at last element, and then we will see if we are able to reach the last element from the second last element. So in this case, from 1 we can take one jump, so we will be able to reach the last element. If we are able to reach the current last element, we will update the last pointer to the next element. Now the last is here, the 1 is the last element. Now we will see if the element before 1 is able to reach this last element. Now here value is again 1, so we will take one jump and we can reach here. So again we will update the pointer last to here. From 3, the element previous element, we can take either 1, 2 or 3 jumps. So again we will be able to reach here from 3. So again we will update the last pointer to this. Now the element before 3 is 2. So from 2 we can take either 1 or 2 jumps. So in that case also we will be able to reach from here to here. Since we have reached the first element, we will return true, that we will be able to reach the last element from the first element. Let's see the other example. At first we will set the last pointer here at the last element. Now from the second last element, we will try to see if we will be able to reach the last position or no. So from here we will not be able to reach here because we are not, We are not allowed to take any jumps from this index. Hence, in this case, our last value will be here only. Our last pointer is set at the last index only. In this case, we can return false. Let's modify this example further. Say we have more elements here. Now, in this case, at first, the last pointer will be here at 1. Now, from 2, we will be able to reach last because we can take either 1 or 2 jumps. So, we will set the last pointer here at 2. Now from 4, we will be able to reach 2 because we can take either 1, 2, 3 or 4 jumps. So again, we will set the pointer here. Now from 0, we will not be able to reach 4. This is not possible. So our last pointer is still at this particular index. Now, in the end of this loop, we can compare if this last pointer has reached the 0th element or not. If it has reached the 0th element, then we can return true. And if it is something greater than 0, for example, in this case, then we will return false. Let's try to code this problem. We will set the last pointer to length of nums -1, and then we will have a loop. The loop will start from the second last element till the 0th element. So we will start it from length of nums -2. We will take a step of -1 each time and we will go till 0. So I'm putting it as minus because the last element is not considered in range. If I plus nums I. So if the index ith plus its value is greater than or equals to the next element, that is the last in this case, in that case, what we will do, we will set the I as new last and this loop will be executed till 0. In the end, when the loop is executed, we will return true if the last has reached 0, or we will return false if it is greater than 0. So we can simply say we will return last less than or equals to 0. Let's try to run this. These two test cases are accepted. Let's try to submit. This is submitted successfully. Let's understand the time and space complexity now. Here, only one variable is defined for which it will take order of 1 time complexity. And here we have executed one loop, which is length of nums time. So the time complexity will be length of nums time, which we can say order of n. So that's all for this problem. If you have any better solution or any suggestions to enhance this particular solution, please let me know in the comment section and visit my channel for more such videos. Thank you so much. Bye.